What's up, everybody? Welcome back to another Wednesday live stream from Scalar Learning, where we tackle SAT problems from Khan Academy, SAT, Khan Academy, the website. We just do a quick sound check and make sure we're doing here. All right, we're going. Good. Sorry this is late. I usually like to do these live streams in the morning, in the AM, before I start my day. Today was just so crazy. I had so much going on in the morning, I didn't have a chance to do it. So I'm doing it now. It's 10:45, 10:46 here in California time. But it is what it is. Wanted to get this live stream out on a Wednesday, like clockwork, like I do, so you can have it. And hopefully you can check this later, even if you're not awake, as this is being streamed live. Definitely subscribe if you want to get more SAT problems and better preparation for the math section of the SAT. And like this video if you find it helpful. That really helps out the channel big time. All right, without further ado, let's jump into it. As always, I'm solving these problems for the first time, which is part of the fun. Now we have root A. We've got this table with root A, root B, root C, on time, late, total. Okay, let's see what this means. Victor decides to try 3 different routes to work for a period of 40 days. In the table above, he tracked whether he arrived to work late or on time each time that he used a particular route. Based on the information above, what is the probability that Victor will be late if he uses route A? So if he uses route A, probability is always the number of times to win or number of times something happens out of the total number of possibilities, total number of outcomes. So we have for route A a total of used 11 times. And then what's the probability that he will be late? Well, he was late 6 times out of that 11. So the probability that he will be late is 6 out of 11. Next question. The table on the left shows the most commonly spoken 5 languages in the world by native and non-native speakers in millions, according to the 2013 SIL Ethnologue. If the relative frequency of Spanish non-native speakers to all non-native speakers, if the relative frequency of Spanish non-native speakers to all non-native speakers was 4.8%. So let's start setting this up in a proportion. I think that's where we're going with this. Of Spanish non-native speakers to all non-native speakers is approximately 4.8 out of 100. Approximately how many non-native Spanish speakers in millions were there in 2013? So let's see if we can figure this out. And this is all 2013. So we have, so look, here's one way we can do this, is I can figure this out by saying we got a relationship of Spanish non-native speakers to all non-native speakers. All non-native speakers is 1237, right? So Spanish non-native speakers to all non-native speakers is 4.8 out of 100%. I think I've set this up correctly. This is definitely a calculator problem. So now all we got to do is do some cross multiplication. Let me get my calculator app open here. All right. Cross multiply. We have 100x equals 4.8 times 1237 equals, and that's divided by 100, because we have to, so basically we got 5937.6, and then we have to divide by 100, and that's how we get that x value. That's how we get that x value equal to 59.376. Okay, so approximately 59. Yay, yeah, sweet. 3 questions left. Dante and his friends ordered pizza for a birthday. They asked all the guests at the party whether they wanted sauce or no sauce, and whether they wanted cheese or no cheese. Okay. The results are displayed in the table above. Dante found that 1/5 of the people who wanted cheese. Let's draw this graph out here. All right. So I'm going to show you why I'm doing this in a second. So let's see, we got 1, 2, 3, and 4. And then we got this split up into 4. 1, 2, 3. All right, let's start doing this. Sauce, no sauce, total. Cheese, no cheese, total. So we know that this is 20 got cheese, 6 wanted no cheese. It's 26. This is 8, and this is 18. Okay. Dottie found that 1/5 of the people who wanted cheese did not want sauce. So 1/5 of these guys, 1/5 of this 20 did not want sauce. 1/5 of that is actually 4. Right? 1/5 of 20 is 4. This is a calculated problem, so you don't have to do that mentally, but so we know that no sauce is 4. What fraction of the people, so that means now we can start, what fraction of the people who wanted sauce also wanted cheese? Well, now we can start filling out this table, right? I know that this has to equal 16, right? Because 16 plus 4 equals 20. Now I can fill out this way, right? 4 plus what equals 8? This has got to be 4. 16 plus what equals 18? That's got to be 2. And look, these add up, so now we're good. But now here's the tricky part. What fraction of the people who wanted sauce, what fraction of this 18 also wanted cheese? It looks like 16. So 16 out of 18, which reduces to 8 out of 9. So that should be our answer. Let's see if that exists. There we go. So that should be right. All right. Next. Football, basketball total. Ori asked 10th and 11th graders at his high school which sport they prefer between basketball and football. The table above partially shows the results. Given that 40%, okay, so now I'm gonna do the same thing. I'm gonna graph this out here, and we've got 1, 2, 3, 1, 2, 3, 4, 10, 11 total. And then we got football, basketball total. Okay. So we got 14 here, we got 12 here, and we got 156 here. Now it says the table shows the partially shows the results. Given that 40% of 10th graders at his school prefer basketball. So if we call this whatever this is, 40% of the 10th graders prefer basketball. So 0.4 of x equals 14. So to solve for x, we divide by 0.4, divide by 0.4. X equals, we can use the calculator. 14 divided by 0.4 equals 35. So x over here, you see how we start to fill in one value, and now we're going to get in really good position. How many 10th graders at a school prefer football? Well, now we can already see what plus 35 equals this. That's got to be 21. All right, 35 minus 14 is 21. How many 10th graders prefer football? It's right here. We just solved it. Okay, last question. Let's set this same table up. One, 2, 3. All right, and then we got 1, 1. Okay, now we got our table. This is yes, no, total, first, second, third, and total. 2, 2, 6, 8, 1, 1, 7, 3, 3, 4, 4, 1, 1290 1239942. All right. Table above gives data about a group of students by whether or not they enrolled in college the year following high school graduation and whether they were first, second, or third in their family. How many firstborn students in the study would need to enroll in college? Okay. Would need to enroll in college. How many firstborn? Following high school graduation in order to provide evidence that being a firstborn is independent of college enrollment. So let's see here. Firstborn. So how many firstborn students in the study would need to enroll in college following high school graduation in order to provide evidence that being a firstborn is independent of college enrollment? Is independent of college enrollment. Let's see. First, second, third. It's 440, 440. So let me see. Oh, I think I see what's going on. We need... I see. I get it. So essentially what they're trying to say, this took me a second to get, basically I think what they're trying to say is that it has no bearing on whether or not they go to college. And I think what it means is if the total ratio, I think that's a pretty hard question, if the total ratio 2268 over 3441 is the same as the ratio of people saying yes to the total amount of firstborns surveyed, then the two are independent. There's no dependence. So this is a calculator problem, of course. So let's cross multiply and see what we get. 3441x equals 2268. 2268 times 1290 equals that, and it's that divided by 3441 divided by 3441. So it should be 850. So 850 should be the answer. Let's see if that's right. This one was tricky, definitely. Okay, so I got it right. And I'm pretty sure that's the logic. Yeah, it's the same thing, right? So they set it up. They set it up in that same way. They didn't explain it exactly. See, they calculated this to be 0.375. And then they went from there. Oh, they actually did it this way. They said this over this has to equal this over this. So a little different. Not really. It's the exact same thing, but that proportion yields the same answer. All right, so that is it. That is my weekly live stream, table data. Hope you enjoyed it. Hope you found it useful. If you did, please like the video. If you want to see more, definitely subscribe to the channel. And I hope you guys have a great rest of your week. Take it easy and have a great night.